Hey everybody, this is another video notes for your notebook here. This is going to be on determinant of a matrix. In your book, this is section 3.7. One thing to keep in mind whenever you watch these videos is, once again, listen carefully, make sure the video is not on mute, write down all the notes, not just the stuff you feel like writing down, and pause the video when necessary to catch up. I'm not going to do this as slow as I would in class, otherwise the video would be 25 minutes long. I'm going to do it a little bit quicker than normal because most of the stuff is pre-written. So pause the video periodically to get caught up and then play to listen to any comments I have on it. So determinant of a matrix. Every matrix is associated with a real number, and that one real number is called a determinant. Now, I should be a little bit more specific here, and it's every square matrix with dimensions n by n, let's say. I'll talk about what a square matrix is in a second. The way we denote determinant of a matrix is either by doing DETA, where A is in parentheses, or what looks like absolute value bars. Keep in mind, you can only do the determinant of a matrix that's square. A square matrix has the same number of rows and columns, such as a 2 by 2, a 3 by 3, 4 by 4, etc. If there's a different number of rows and columns, then you can't find a determinant for it. We're only going to do determinants of a 2 by 2 and a 3 by 3. The video will cover both. Let's start with a 2 by 2 matrix. The general method is to subtract the product of the elements on the diagonals. All that means is you start on the top left and multiply A and D, and then you subtract B times C. So this is the general rule. You want to write this down. 2 by 2s are very easy once you get the hang of it. It's quick. So let me see here. Okay, if I want to find the determinant of this matrix here, I'm going to do 5 times 1 minus 4 times 3. To find the determinant of this matrix, I'm going to do 6 times negative 4 minus negative 2 times 1. So if drawing that little x helps you, then do that. So determinant here is 5 times 1 minus, remember you always subtract 4 times 3. So I have 5 minus 12, negative 7. That's the determinant. This one here, 6 times negative 4 minus, be careful here, negative 2 times 1. That's negative 24 minus negative 2, which is really negative 22. I want you to try this one. Find the determinant of 2, negative 5, 0, 6. The fact that I'm just using these bars here without the little hooks means determinant. So find the determinant of that. You should get 12. Those should only take you a second to do. Let's move on to a 3 by 3. 3 by 3s are a little bit more complicated. Repeat the first 2 columns to the right of the matrix. So this is not nice and quick like a 2 by 2 where you're just subtracting 2 numbers. This one here, we cannot just say, oh, let's do this minus this. It doesn't work like that. The way we have to do it is take this column and repeat it here, and take this column and repeat it here. So I'll write this down. This is the general rule. I'm just going to use letters in here to keep it general. The way you do a determinant for a 3 by 3 is you multiply the elements of the 3 diagonals going downward. So start at A times D times I, B times F times G, C times D times H. You add all those 3. Notice there's plus signs. Then you're going to go from the bottom left up, and you have 3 diagonals going this way. G, E, C, H times F times A, I times D times B. Each of these, notice they are in blue over here, each of them is subtracted. That's why there's a little minus. So minus that, and minus that. There's a lot of mistakes here made with the negatives and the subtracting, so please be very careful. So let's go ahead. I'll do 1 or 2 with you, and then I'll give you one to try. So make sure you have the rule written down. This is the first example. I want to find the determinant of this matrix. So I'm going to use absolute value bars, or what looks like absolute value bars. And what I'm going to do is repeat the first 2 columns. I'm going to do this, plus this, plus this. So add all those guys. And then in blue, I'm going to do this, this, and this. subtract all those. If doing the arrows helps, I would recommend it. I find it helpful. Go ahead and do so. So let's multiply it. 2 times 1 times negative 2 is negative 4. Negative 1 times 0 times 3 is 0. It's always nice when there's a 0. Negative 3 times 4 is negative 12. Negative 12 times negative 4 is a positive 48, so add 48. Now I'm going to be subtracting, so here's a minus. Minus 3 times 1 times negative 3, that's a negative 9. Minus negative 4 times 0 times 2 is 0. Minus negative 2 times 4 times negative 1. That will end up being a positive 8. So go from left to right. Negative 4 plus 48 is 44. Minus a negative is plus, minus 8. 44 plus 9 is 53. 53 minus 8. Here's our next example for your notes. So write this down as example 2. And again, make sure you write this whole thing down. I want to find the determinant of this 3 by 3 matrix here. I started setting it up. I just rewrote it in those bars, and I repeated the first 2 columns. So I'm going to do this, plus this, plus this, and then I'm going to do, this, or minus that, minus that, minus that. So this is the last one. I'll do all out with you. 4 times 1 times 3 is 12, plus negative 2 times negative 2 times 2 is 8, plus 0 times 1 times 5 is 0, minus 2 times 1 times 0 is 0, minus 5 times negative 2 is negative 10. Negative 10 times 4 is, careful here, negative 40. Minus 3 times 1 times negative 2 is negative 6. So all you're going to do, that's a little messy there, hold on. I'm going to go from left to right whenever I do this. And just be careful with your positive and negative numbers here. 12 plus 8 is 20. Ignore your zeros. Minus a negative becomes positive. 20 plus 40 plus 6 is 66. That is the determinant of A if we were to call this matrix A. I want you to try this one. So I want you to do the determinant of 2 times negative 2 times, or 2 negative 2, 2. 3 negative 3, 3. 4 negative 1, 4. You should end up with the answer of 0. Your determinant will be 0. So do the work for that to make sure you're okay with it. If you don't end up with 0, we'll compare numbers on Monday. Last thing I want you to write down for this video is this screen here. We're going to use determinants. We're not just doing this for the heck of it. We're going to use it for something called Cramer's rule. Cramer's rule is something you've never seen before. You might have seen determinant of a matrix last year with Mr. Jackson. Cramer's rule is new. So Cramer's rule is another method used to solve a system of linear equations. For example, like this. You already know several ways to do this. In fact, you know 4 different ways. Substitution, elimination, graphing, that was the intersection point, or wherever they intersected, that was the ordered pair. And you also know how to do it on a graphing calculator using inverse matrices. So you had your coefficient matrix A, your constant matrix B, and you used it to get your variable matrix X, and you did A inverse B. Last method that we'll learn is Cramer's rule. What I want you to recall is that if we had this system right here, then we called the coefficient matrix A, B, C, D. We're going to call the coefficient matrix A, just like before. We can use Cramer's rule when the determinant of A is not 0, and we'll use it to find the one solution to the system. So this is the end of the video notes. Make sure you have this whole thing written down because we're going to pick up right here in class and we're going to do some problems, and I'll get you to work on those. Have a great rest of your weekend.